Welcome back, students, to the second session on Introduction to Turing Machine. So, in the last session, we have discussed about Introduction to Turing Machine along with the difference between finite automata, push-down automata, and Turing Machine. So, why those differences are mentioned previously is in order to show the highlights of Turing Machine and what are all the advantages are available in Turing Machine comparing to finite automata and push-down automata. So coming to the elements of Turing machine, these are the 6 major elements. One is finite, infinite input tape, which has unlimited memory. Next thing is input cells. Then third thing is inputs, which is occurred in the input cells. And fourth thing is read or write head. So the read and write operation can be performed in both the direction, either in right hand side or on the left hand side. The next thing is erase hit, and last thing is finite control. The finite control perform all these operations, the read operation, write operation, as well as the erase operation. So when we are coming to the working of the Turing machine, as already mentioned, Turing machine is an unlimited memory which contains an infinite tape. So you can either read or write the input in both the directions, either in right hand side or in the left hand side. At the same time, if you want to rewrite the input, you can perform the erase operation and you can rewrite the input. And the Turing machine can be concluded with the final stage, either with accept state or reject state. If you are giving the right input, it will be going to the accepted final state. If you are giving a wrong input, it will be going to the rejected final state. And some of the operations cannot be completed in Turing machine. Those things are called as a halting problem that will be discussed in the future lectures. So here, if you are not getting any final state, means that problem is mentioned as an undecidable problems. So undecidable theories and undecidable examples will be taught in the some other sessions. Okay. Now we will see what are the basic operations performed on Turing machine, how those operations are performed. Okay. So normally the head will be pointing the current state and the current tape symbol, and by using the current state and the current tape symbol, you can rewrite a new state. You can rewrite a new input based on the current state, or if you want to change the state, that is also possible in Turing machine. So here the operation is done in both the direction, either left or right. Each time one input can be performed in the input cells. Okay. So when you are coming to the definition of Turing machine, similar to push-down automata, Turing machine is also having 7 tuples. So these are the tuples. One is capital Q. Capital Q represents the finite set of states. Tau represents the finite tape alphabet, and summation is the finite input alphabet. So which will not be containing the blank symbol, because the blank symbol was mentioned in the input tape symbol, that will be coming with tau. So okay, that is available with tau. Then del is the transition function or the transition diagram. So you can perform the del operation with the help of the finite set of states and input tape alphabets. Okay, and you can process the input in both the direction, either left direction or right direction, as well as if you want to stay in the particular state, that is mentioned as H, that is called as halt. Okay. So you see here, we will take this particular example.